recording this meeting starting now.
Great, thanks, Gary, and welcome, Adrian. So this meeting is really meant more to be, one-way transfer of information. So, Adrian, please feel free to jump in and ask questions as we go. I am recording this because I think it's going to be easier to make this available, this and or Laura's session on Wednesday, to make this available asynchronously to the board. So everybody can kind of get an idea of where we're at, get an update, see the demo that I'm going to present for the app, and then get an understanding about what our quote unquote ask is, and next steps and tasks for the board. So welcome, and I'm going to dive right in. So our goals for today are to summarize progress since we last met this spring, to demo the current hydrogen application, and then to outline our next steps and timeline, and then really to start recruiting beta testers. And we're not asking everybody on the board to be beta testers, but we are asking the board to provide feedback on the app and to provide input on likely beta testers. So just as a reminder, we're sort of halfway through this whole process. Phase one, which we spent 9 months building our team, developing our concept and rapid prototyping. Phase two, which we are closing out year one of. We're building our minimum viable product in a year, setting up our scalable platform and sustainable business model. And then phase three is really about transitioning into sustainable long-term operations. So just quickly, our project overview. Project hasn't changed much, but just to make sure everybody's on the same page. So our mission is to better predict and prepare for the risks we're facing by putting the best hydrologic science directly in the hands of decision makers. So on-demand watershed forecasts, more than just stream flow and seasonal outlooks. And it's a web-based platform that now generates seasonal forecasts of a watershed conditions on demand. So just briefly how it works, we've covered this quite a bit, and this also hasn't changed. We have physics-based modeling of watershed dynamics that we then train a fast-running machine learning emulator on those watershed model results, and then integrate this within a national hydrology framework. So what makes us a little bit distinct from other products or other platforms really are these longer timescales. So we have seasonal forecasts. Weather forecasts are generally 2 weeks. Our forecasts are out 3 months, but can be, of course, longer. This is just the first first application or first use case of this platform. We have unique variables, so we simulate everything from bedrock to the top of the canopy, and in particular groundwater and soil moisture, not just stream flow. Better performance with extremes. Our physical simulations allow us to better capture these potential futures. Namely, we can train the ML on simulations of drought that have not yet occurred. So that allows us to push beyond just purely data-driven type approaches. And then it's all built with a very modern software architecture. So the application I'll show you is completely built in Kubernetes. So it's scalable, using very modern technology and scalable out to the cloud. So it's, it's a highly scalable application. So I'm going to jump right into the software demo. But first, Adrian, I'll check to see if you have any questions before I jump in.
That all looked good.
Terrific. Okay. So I'm going to reshare my screen. So what you're seeing is kind of a teaser page. So the app is set up in two different ways, or sort of two different entry points. So this is our website, hydrogeneration.org, and this is just a brief overview of the hydrogen project and just kind of a placeholder of what we're doing. And then we have the hydrogen app, which is currently hydrodev.princeton.edu. And this is, the portal, the entryway into the application. So users can log in. I'm going to log in with Google. This is Keycloak authentication. So basically, you bring your credentials with you and authenticate, and then we allow access. So you can authenticate with a number of different platforms and products like Google or Facebook or GitHub, et cetera. But what that allows us to do is we don't actually have to keep any passwords. We don't have to keep any sensitive information. We just have to link up your authentication through one of the other platforms with being a valid user of our platform. So that makes our platform more secure. So here's the main dashboard. Here's the sort of the main entry into the web page. And you can create a domain. You can look at your existing domains. I'll walk through that process. But note also that we have, help screen and kind of a technical explainer that are also being built that I'll talk about in just a second. So we can create a new domain. So I'm going to call this EAB test and the date. And then we go to define watershed area. And this brings up a mapper of the United States. This is our CONUS 1 domain. And we're showing outlines of the USGS hydrologic unit code, watershed, HUC watersheds. You can choose from HUC 4 to HUC 10 currently. And this is our CONUS 1 domain. And then we're ready to go with our CONUS 2 domain, which is currently being finalized and developed. And the CONUS 2 domain is the entire contiguous US. So I'm going to demo based on our CONUS 1. And I'm going to zoom in and pick a watershed that we use a lot, which is Lower Clear Creek. So I click on this watershed, notice I get a watershed outline, and then I can go ahead and create that domain. Pretty straightforward stuff. Now what's being developed here, you see here's my EAB test. Here's our status bar. So what's actually happening is more than just like clicking on a page. We're actually pulling in current conditions. We're actually pulling in a bunch of data sets. We're creating a directory, and we're pulling together some basic information about the watershed. So we can go in and we can explore the results now. And this is our demo explorer. We can look at water table depth current conditions. We can look at soil moisture current conditions. And then we can look at observations. And so we've ingested, using the Hydro data platform that we're developing, we've ingested a bunch of different observations. We're only showing stream flow here, but we have stream flow, we have water table depth, and we're pulling in SWE and soil moisture and other observations. And we have a point observation explorer that is just a widget that explores, for example, hydrographs, and we have a cron job, so we're continuously updating all of these data from the USGS. You can see that our last update was last week, and you can kind of scroll through and explore the different data sets, et cetera. And you can click on any of the watershed, any of the observations within the watershed. And then where the application comes in is our weather scenarios. And so what we can do now is we can generate scenarios, and we have a bunch of different options. So we can pick from the past 40 years of archive forcing, we can pick average, we can pick hotter years, wetter years, drier years, all for that particular watershed that we've chosen, or we can pick the CPC, so the Climate Prediction Center forecast. And so this takes the Climate Center prediction 3-month forecast, and then pulls from the archive, pulls weather forcing from the archive that matches the CPC forecast for this watershed. So this is a true 3-month outlook or forecast. So we click build forecast. And so now what it's doing is it's actually pulling, you can see it's generating scenario, it's pulling an ensemble from the archive, and then it's actually going to run the machine learning emulator 3 months forward for the watershed that we've chosen. You can see that it runs very fast. We've got the status bar here, and it's cranking through, of course. And so now our scenario is ready. So we've got full simulation. We can go into our Explore results, and we can look at our weather scenario. Now notice that we have the CPC forecast here. this is the CPC forecast that was chosen. We have 4 different runs. That's completely settable within the app. This is just for the demonstration purposes, but this can be a more full ensemble. And we can see different variables that are pulled in from the app, showing temperature or precipitation, all basically statistically pulled from historical data to match the 3-month forecast. And then we can jump to the watershed forecast, and the watershed forecast again is now the emulator simulation for these 4 ensemble members over looking 3 months into the future based on the CPC forecast. This is a daily simulation. And so you can see we're just plotting change in soil moisture, we're plotting change in mean water table depth, but this is a true integrated forecast of water from bedrock to the top of the canopy. And so these widgets are completely flexible. We have a widget builder that we've developed that pulls in and serves these different widgets. And so we can just look at the change in soil moisture, say, or the change in water table depth, just as a way to show that we've got full 3D simulations in time. So we could, if a user wanted to, look at a change in soil moisture at a point, plot that out across the different forecasts, et cetera. So it's a full scenario simulation of all the water within our watershed of interest. And so lastly, we also have help throughout the entire application, including excluding explainers. So notice that we've got context sensitive help here, but then we can also jump over to our technical explainers. So our education outreach team has built a number of different technical explainers, and we'll continue to develop these for a whole host of different aspects of the application. In fact, if we go to the help page, we can see we've got a glossary, we've got our technical explainers that are being built out, and then we have our support tags and things like that. So it's a really pretty extensive kind of robust application. And then lastly, if we go to explore results, we see that we can download our results. If we want to grab, say, the current conditions or observations, we can grab the current conditions and then download those to our own local computer. So that's the kind of the end of the demo. I will pause and see if you have any questions, Adrienne.
So with the Climate Prediction Center, when you did that scenario and it came up with 4 different runs, what's the difference between those 4 runs?
So those 4 runs are chosen. So the way the Climate Prediction Center forecast works is it basically says probabilities. It's a probability distribution of precipitation and temperature over the next 3 months. And what we do, because it's just like any other weather forecast, where if there's a 20% chance of rain, that's actually pulling from a distribution. So there's a distribution of, say, if you have 10 ensemble members and there's a 20% chance of rain, then 2 of them have precipitation, 8 of them don't. And you would run all of those forward. And so what's happening in those ensemble members is that we're doing a distribution matching of the distribution of precipitation and temperature from the CPC forecast, and we're matching that with the with real weather from the past. So it's drawing from 40 years of archived weather that we have for the next 3 months. So it's drawing from half of September, October, and November from the historical archive. And then it's matching the distribution so that if there's above average precipitation or above average temperature within the distribution from the CPC forecast, those distributions are matched by the ensemble that you see there. So it's a true kind of forecast, drawn from past observations for, now moving forward 3 months in time, 90 days
Okay.
forward.
Impressive, nice.
Thank you. Yeah, it's been a lot of work by a lot of people on the team. So I'll jump back to the presentation. And just kind of quickly to wrap up, so sort of, where we are in development process. So as I mentioned, we have now HydroFrame and HydroData are the two platforms under the hood. HydroFrame is the sort of the national physically based simulations that we're drawing from, and then all of these static watershed properties. And then this new HydroData platform that has emerged out of this project is really pulling in both point observations of stream flow and groundwater from our national organizations, but also remote sensing and gridded data products. So these are ingested in HydroData, they're updated weekly and stored, and they're used either behind the scenes in the application or directly. And a little bit more about what HydroData does. So we're pulling from NASA, USGS, NOAA, and National Weather Service to pull together these data sources into the Princeton Hydrologic Data Center, the PHDC, and there's processing to basically provide a single API right now for internal access. So Hydrogen has an internal API, but then that will be something that will actually be outward facing. So we'll have an outward facing API that'll be one API to access all of these different data sets, both for modeling current conditions and then in the near future model comparison. So we're continuously updating these. Our data sets are currently on HydroData. They're all processed for QA/QC, fast access for our HML team through the standard API, and they're automatically updated. And currently we have stream flow, groundwater, we're pulling in soil moisture, snow, precipitation, and temperature. And the precipitation and temperature are really important because these are the NOAA NWS products that are used to develop the current conditions. So we need these to update our current conditions. And then just lastly, kind of walking through the different components. So we have the hydrologic emulator, which is what you saw there. This gives us the physically based simulations, current conditions, which is another full ML process to provide sort of how much water there is today, and then the weather scenario generators. And just a little bit more about where we're at with current conditions. So we're using derived soil moisture and water table depth to show state of the watershed, and then to calculate an initialized pressure field for the emulator. So we're using SMAP, remote sensing data, downscaling to 1 kilometer using watershed properties from the model. And then we're using machine learning emulators to basically provide an initial condition for water table depth that's purely data driven and downscaled to 1 kilometer as well. This is really a deeper dive into your question about the weather scenarios. So as I mentioned, we're using this historical resampling approach, and we're a sample based on the Climate Prediction Center seasonal outlooks. And so, our samples based on a current condition are also, our samples are also based on the current condition that a user wants to explore. So if you just want to say, give me the 5 wet or the 4 wettest, half of September, October, and November's from the past archive, or the driest or the hottest or the coldest, those are already in place, and it would just pick, from the archive. But then if you use the seasonal, the CPC forecast, it's then, as I mentioned, it's actually matching the distribution from the archive. So application architecture, as I mentioned, this is running on Kubernetes. So it's a microservices approach. So each component runs as its own microservice, as its own scalable component, and they all interact using what's called a message bus. So there's a message bus communication between the components. They all get data from the Princeton Hydro Data Center, and they're all containerized into Argo workflows. We use Kubernetes for container orchestration, which makes us very easily cloud scalable. And as I mentioned, message bus, and then all of the data sits on the PHDC, and then is served out to the app only, for the watershed that you need, or only in the data that's needed. And then, as I mentioned before, we have a Keycloak login server. And as I mentioned before too, we're also leveraging elements of the Cyberus technical stack. So this greatly accelerated our development. And this is a very standard architectural design, API access to all services. So not only can you access the front end, but we're going to provide a direct API for users who want to just develop their own interfaces to our architecture, and then integration across services, container orchestration, managing distributed workflows. Where we're at right now is that we are scaling out. So we've done a proof of concept, scaling out to the Cyberus, which is like a Jetstream type architecture, which is based very much on the same cloud-based architecture that you would have in AWS, Google Cloud, or Azure. And so that proof of concept is the first step to being able to launch fully in the cloud. So the data still sits at the Princeton Hydro Data Center, but then the whole rest of the app runs in the cloud and is then completely scalable. So our next steps, as I mentioned, we are undertaking simulation-based inference, which is calibrating the emulators to observations, additional training for extreme events, which expands our training data, and then this national model evaluation framework, which I mentioned will use this Hydro data application, and then ML operations, so that we have standardized approaches for saving and versioning all of our different trained emulators. Currently, we're undergoing performance testing, portability testing. As I mentioned, we've deployed on Cyberus and are testing cloud development. We're setting up standard QA/QC and unit tests, et cetera, and implementing federated data and metadata management. And then starting to think about, how we keep track of quota and time and chargeback for this. So our business model supports 2 tracks, and the idea is still the same, that we have a nonprofit company that develops and supports the national platform through paying users with a range of product and customization options. But the idea is that this is a heavily subsidized nonprofit platform that really democratizes this availability of these data and models. But nonprofit is not free. We still have to monetize this. We still have to find ways to support the nonprofit operations. And then this will also dovetail in our ongoing research program, supported by federal grants, using our backend platform and reusing these ML workflows to continue to sort of advance the research. Now, our go-to-market plan, or kind of our timeline, we're right here in September 2022, and we're ready for testing. As I showed you, we have a demo. So we're starting pilot studies, which is this user interface improvements and feature prioritization, market research, and then in terms of outreach, we're really looking for 1 to 2 large clients who would be interested in moving forward, either with a custom interface or more direct engagement. And that would be sort of winter to spring. Training and outreach. So we're in December, we're planning our first publicly accessible national release. This will be a free version, sort of an extended beta test. And that will go hand in hand with training and outreach. So working with early adopters, piloting custom applications, again, with these 1 to 2 clients, and then testing payment options. So, it's a lot of our potential users are in the public sector and would not themselves pay, but would be contracting or would be paying for this in a more broad sense. And then other users are consultants and might pay directly for this. So there's a lot to sort of work out in terms of the different payment choices and pricing levels. And then as we move into the spring, we have the first pay options available and marketing and training, and a lot of, sort of setting up the infrastructure for that. So our first prototype MVP was in June. We're sort of going into this limited release now. I'm not going to dive into the details too much, but as we move into our first national platform release in December, we really want to dive into our hands-on user testing, front-end app refinement, help and education modules, portability, adding features, and implementing QA/QC. And this is really where the board, where we'd love to have engagement from the board at this point, right? So we now have this beta test platform, that's ready for testing. And this testing sort of goes in two pieces. It's kind of hands-on user testing and pilot studies, and then really understanding the education modules and training needs. As we move forward to these more targeted user studies, it's really important that we have a good idea about what, and then subsequent releases, what our user needs are. So what are we asking? So takeaways and outlook. The big thing that we want from you is to identify beta testers, and we're not expecting that every board member is a beta tester, that every board member identifies a beta tester, but that we open this up to the entire board to suggest, and you can provide feedback now. So we have a Google form that should be live and work with this QR code and is set up for feedback. So not sure.
Could you put that link in the chat, because we can't click on that link live.
That is a good call. This is the end of the presentation, so I'll stop sharing, and I think if we put the link in the chat too, it'll be available in the recording as well. That's why I put the QR code in there, so that you could. Sorry, let me grab. It's not giving me I made a tiny URL of it so that it wouldn't be quite so. All right, that should be the link to the form. And I'll open it up for questions.
So once the recording's available, I'd like to send it to a couple folks in my company, including some that are familiar with machine learning and hydrology and such.
Mm-hmm.
So
absolutely, yeah, that would be terrific. So
yeah, then I can.
So that's exactly the response we were hoping for. So many of our board members, for example, Water Now or Green Infrastructure Stormwater Alliance, our Leadership Exchange, are really kind of representing a number of different constituents. And so we're hoping that you can kind of provide a filter for us to pass this on to colleagues who you think might be interested. Of course, you're welcome, of course, to also volunteer to be a beta tester, but and that's the reason for the recording. That's the reason sort of for the entire kind of more broadcast and feedback form of this. So please do, that would be great.
And then my other question is, like, when I saw the watershed boundary for the demo watershed, it looked a little funky to me. Is that because it's based on a grid system?
Yes, so everything is based on a grid system. I also chose just the lower watershed. So in the demo, to have everything run like instantaneously, we have selected watersheds that we pick that run well, that run, it'll run anywhere in the US and it'll run at any size, including the entire US, but the computation cost, even with machine learning, goes up quite a bit. And so we're gonna have that interface that you're seeing is actually currently being redone, and we'll have other ways that you could pick sort of the entire watershed instead of just a sub watershed. That was just the lower Clear Creek, so it wasn't even up to the full watershed boundaries. And the idea is that you might pick, you know, the watershed and all of the, you know, the sub watershed, and then every watershed that feeds into it, which I think is part of what you're referring to. And then it is on our CONUS 1 grid, and then we have another one that's on our CONUS 2 grid. And so that's maybe the other piece that you're seeing there as well. But you know, these are evolving as we build out the other aspects of the beta testing or the app.
Okay.
Reed, I think something that with regard to beta testing that people will ask is what kind of, do we know, what kind of time commitment will we be asking for people?
Yeah, I think that's a really good question too. I mean, I think it's really up to you, up to the individuals. So I think the time commitment is not huge. Any time commitment is a time commitment, obviously, and it's an ask of your time. But the idea is to have this, the beta test, not longer than a month in length, total length, and then, you know, really to respect the board members' time, to make it as, you know, kind of efficient a process as possible.
Okay.
Terrific. All right. Well, if there's no more questions, we can stop the recording, and thank you very much for making time to jump in.
Yeah, thank you.